This is a presentation of SBE 15, New York City.
So when we turned 50 3 years ago, they said, what do you want to do for our 50th anniversary users group sessions in Vegas? And I said, well, why don't we do a tip a year? So tips and tricks, one for each year. And that's kind of how this evolved. And so I've done it several times since then. Of course, we're not 50 years old anymore, but I just kind of adapt it to fit the time frame we've got. So that's our whole session. It's just things that I've run into. By all means, I know everybody's muted automatically, but if you want to interrupt me with anything, just unmute, throw it up in the chat. I will drag the chat window down to where I can see it while I'm thinking about it. So we've got that right there. We can do it by text, we can do it by speech, whatever works for you guys. So yeah, tips and tricks, that's the whole thing. I make the argument that I mean, obviously I do care what brand of transmitter you use, but for the purpose of longevity, it doesn't matter whose logo's on the front. You keep it cool, keep it clean, and keep it well grounded. It's going to live a lot longer no matter what brand it is. So the first thing I put up here was how you calculate your waste heat. The one thing that isn't in the big format or the big page, and I'm not going to read the wall of text. Are you recording this, Jeff? Thumbs up, thumbs down?
Yes, I recorded this and I posted, which will be fun for somebody watching this recording to know that it's recorded.
Right. Now, the other thing, if anybody does want a copy of the slide deck later, just shoot me an email, reach out on Facebook, LinkedIn, whatever, and I'm more than happy to send a PDF of the slide deck out too. Or just ask Jeff, he knows how to find me. So yeah, waste heat's the big one. All you need to know really is your TPO, your output power, and your efficiency. The rest is pretty basic. You know, once you've got that figured out, then calculating waste heat in either BTU hour or tons of air conditioning is pretty easy. And remember, when you calculate this number, all you are looking at is the waste heat from that piece of equipment. Now, if you put that piece of equipment in the building and the sun shines down, then the building's going to heat up, so you've still got convection heat. I've had people who got this heat load number from me, very dutifully installed a transmitter, and that was the size of the air conditioner they put in, and they wondered why it didn't do the job in the summertime. So definitely, you know, that's one of those other things you want to factor in there. If you're forced air instead of air conditioning, and in this part of the world we can get away with that pretty well, make sure you move more filtered air into the building than you extract from it. That makes positive pressure, which means that you're leaking air out of every crack and crevice instead of sucking dust into every crack and crevice. You walk into a lot of sites where you'll have an exhaust fan but no intake fan whatsoever. So that's what happens. The exhaust fan creates a negative pressure zone that just sucks dust into everything. And I mean, I've walked into sites up here, it's dandelions in the spring. In the Midwest, it's cottonwood season through June and July. Down south, it's cotton season into August and September. But I've walked into sites where the back of the transmitter just looked like a teddy bear exploded. And, you know, we try to avoid that as much as we can. Now, I've had a lot of people tell me or ask, how often do you change the fan filters? And the short answer is as often as your site dictates. Because one site to the next, even two sites in the exact same place, will have different requirements depending on the filtering, on the air handling. I've seen sealed sites that were air conditioned that maybe had the filters on the transmitter changed every 2 or 3 years. You've still got to keep the compressor, the condenser coils clean, and you know, heat exchangers on a liquid cooled system, whatever you've got. But yeah, just make sure that you do clock the maintenance based on that. And I've run into more sites than I care to admit where when you look down from the top, they're blasting the air past the back of the transmitter at 1,000,000 miles an hour, and almost none of it goes into the transmitter. You can have the best airflow in the world, but if you're blowing it by the equipment you're trying to cool, not going to do you any good. By the same token, bless their hearts, Bard air conditioners, awesome for offices and home use. I mean, they shoot the cool air out the top and it settles down because cool air sinks and hot air rises. Works great for cooling spaces like that. In a transmitter facility where the air intake is usually at the rear and the hot air exhaust is almost always out the top, those type of air conditioners are built 100% upside down. So you really do need to do a little creative ducting to reverse the direction of airflow so that you're not pulling the cool air away from the transmitter intakes and then just mixing the cool air up top with the actual transmitter exhaust. So you get a lot more efficiency. You'll get better life out of both your transmitter and your air conditioner if you spend $1,000 on sheet metal work in that case. And I've seen a lot of sites like that where we did do a little bit of sheet metal work, and it made all the difference in the world. Okay, like I said, air filters, I can't tell you how often to change them. That's a pair of 40 kilowatts from our first gen 40 kilowatt way back. I think it was 2007. Funny thing is, Mike Todd just put the construction pictures of this site on, it's either the Broadcasting Club or the Broadcast Engineers Facebook page. I've probably seen some of them. So anyway, absolutely set the filter. Your site will dictate that more than I ever can. If you do have a transmitter that uses metal mesh filters, which are great for LTE interference, but they require a little more maintenance, number one, don't put them back in wet when you wash them, and I have seen that happen too. And number two, there's this little glue type stuff, filter coat, that needs to be sprayed on them. By the way, if you do have metal mesh filters and you are using filter coat, be aware that, forget the name of the company that makes it already, but they are going to discontinue it in about a month. So if you need it, order it now. And again, we use them. I think there are others who use them as well. Now, there are alternatives as well. I saw earlier today, I did a quick Google for filter adhesive and found some other stuff. Keep it well grounded was the third thing. These, like I say, this is my big three. If I only ever did 3 tips ever again, those would be the 3. But keeping it well grounded will make a huge difference. Here's something that you got to think about. And I beat the drum on this, and we'll see more about it in a bit. Everybody knows I talk about ferrites, probably more than I should, because sometimes we get distracted from the real message. And ferrites on their own are only a small part of the equation. They're just like the added insurance, if you will. The 2 critical components are proper single point grounding and decent surge protection. And I'll tell you why, and think about this for a second. So I've got a surge protector that's usually an MOV. An MOV clamps and provides basically a short circuit path. So it's connected between the AC lines and ground. Easy breezy. And most people think, yeah, so when the surge hits the power lines and that voltage spikes up, the MOVs clamp and that dissipates, directs the surge to ground. And that's true. But most people wouldn't believe how rarely damage is being caused by AC surges. When you've got a 600 or 800 or 900 or 1,000 plus foot lightning rod in the backyard, and you drop a couple of 100,000 amps of current down that thing, E equals I times R. Earth has a resistance, ground strap has a resistance, everything has a resistance. So you run a massive amount of current through something with a resistance, what do you create? A voltage. At that point, ground has become much higher potential than the AC lines. Surge protector clamps and dissipates that surge out on top of all those millions of miles of wire that the power company provides. So that is why surge protectors and ground together are so critical. You need both. The ferrites, all they do is basically twofold. They create a little bit of a choke. Because they are ferrous, they will induce an equal and opposite surge between center and shield on a coax, or feed and return on an AC line or an audio line. So it keeps the potential difference between the two a lot closer, reducing that potential point of impact. And like I said, they add a little bit of a choke, so that path looks like a little higher resistance than it did before. Remember, with lightning protection, we're playing a game of we're playing a voltage divider game. You start at the antenna, you head back, and you look for places for that lightning energy to go. And if the easiest path is through your equipment, you're going to replace a lot of stuff on a regular basis. This is physics. We can't stop lightning. but we do have a fair bit of control over where it goes, and that's done purely by how we do our grounding and how we install our surge protector. Adding the ferrites, again, icing on the cake, but on its own, it's not going to do a whole lot. Talking about how we connect things, I'm going to say this now, and I'll say it about 8 more times in the next 22 minutes, 32 minutes, give or take. I hate compression connections. Anytime you have a stranded wire in a compression connection, whether it's a ground clamp going to a ground rod, whether it's a stranded wire into a circuit breaker, it's going to work loose. It's not a matter of if, it's a matter of when. Copper is malleable. It will compress to displace air within the connector. So unless you're putting a lug on with a proper hydraulic crimp tool that displaces all of the air, that copper will deform to displace that air, and that connection just became a little looser. So like if you're running 6-gauge stranded into lugs for the AC connection on a new transmitter, you tighten them down, then you come back next week, you tighten them down again, you come back next month, you tighten them down again, come back a couple of months later, tighten them down again. At that point, you can probably say they're okay. But I just, and the same goes if you're running like a 2-gauge copper wire, that 1/4-inch copper cable out to a ground lug on a ground rod, not a fan. So definitely check those. This little FLIR camera that I'm showing in this picture, this is my old one. I just ordered a new one today because they gave me a new phone and it's got a new connector, needs a new camera. But this thing plugs into the port on your phone. You can get them for iOS with a Lightning connector. The current ones for Android use a USB-C. Apparently going forward with the iPhone 13 or 14, we'll probably be using USB-C there too. But regardless, FLIR.com. The one I bought today was $230 plus tax. I think total was just over $250, and it turns your phone camera into an infrared camera. It gives you a pretty detailed picture. Remember that all the rules about emissivity and thermal reflections apply. So if you take a picture of a shiny object, you're not going to get an accurate reading. But if you have a site and you put a little tape X on the floor or do whatever you do, and you walk in and you take a picture of your breaker panels with that camera from the same point all the time, you've got a reference. At that point, next time you look in, you can see if anything changed. Just as an example, we don't really care what the absolute temperature is. All we care about is the relative reading. Is this thing getting warmer or not? If it's getting warmer, why is it getting warmer? So for $250, a thermal imager, and I mean, you can get the little point and shoot fluke infrared thermometer type things for even less than that. Worth their weight in gold. I have had a FLIR camera in my laptop case for about 6 years now, and I've hit my records so far for me is 185 degrees Fahrenheit on a circuit breaker. And I had one customer, we were talking about this last week, showed me a picture showing 229 degrees Fahrenheit on a circuit breaker. He said it was just to the point where the Bakelite was starting to get soft, and I allowed, as I didn't know Bakelite went soft, I'd only seen it in hard and burned. So, yeah, absolutely worth its weight in gold. And definitely check connections. That's a much, much younger me tightening the input connections on a, looks like an ND10 power amplifier. So I'm going to guess that's probably Mexico. Critter proof. The fall's coming. The critters are going to start looking for places to hibernate. Don't use steel wool and great stuff. Use stainless steel or copper wool because they won't tend to oxidize and disintegrate. And regular steel wool, the mice will chew through that stuff like it's candy anyway, and then you're just going to have the same problem you had before. By the way, if you're critter proofing, one of the cool things you can do is pick the brightest, sunniest day you can, go into the building, turn all the lights off, and then look for where the light's sort of glinting, because the 1/4-inch hole is big enough for a mouse to get in. And if anybody's had to clean a 1/4 inch of mouse paste off of every horizontal surface in a broadcast transmitter, I'm here to tell you that's not a lot of fun. Actually, I shouldn't say it's not a lot of fun. I don't know. I walked in, looked at it, and said, nope, I'm not working on this. You do it. So, yeah, absolutely. Definitely pay attention to that. Oh, yeah, I mentioned something about ferrites a little while ago. Like I said, on their own, they're not a solution. With good grounding and surge protection, they can help make a difference. So again, it's a matter of degree. Every little bit that we can make the transmitter or the audio processor or the STL receiver look like a less attractive path for that surge energy, the better off we are. So they're what you do last after you've done all the other things right. Okay. This is a huge one. As you were talking about earlier with the both quantity and the age of engineers starting to hit the extremes, low on one end, high on the other, we need to start really focusing on safety. I mean, I'm not going to ask for a show of hands, but I'm willing to bet I'm not the only one that's put in a full day of work and then spent 6 hours at a transmitter site crawling around something that I really had no business crawling around. You know, and when I say full day of work, I'm talking 12 to 14 hours. So my record, I flew to the Philippines once, 27 hours there from here in Eastern Canada. And I get there, it's 1 o'clock in the afternoon, and they're like, well, wide awake, bright-eyed and bushy-tailed, let's go to work. And I was young and dumb, so I said, sure. I had been awake for 40 hours when I dropped the coax and cracked my kneecap. So I don't work tired anymore. That was a heck of a painful lesson. Highly not recommended. By the way, right-hand picture, if you use lockout, tagout, and you really should, don't leave the keys in the locks. It's not recommended. But if you're the only one on the site, and I know this engineer, and he's not with us anymore, but not because of this. Anyway, he made a good point. He says, I use lockout, tagout when I'm the only guy in the building. And I do it specifically because the act of going back and undoing the locks and taking the lockouts off makes me slow down and think, did I take the grounding stick off the out of the filter? Did I restore the interlocks that I had to bypass in the process of testing? And that's the kind of issue we run into because we're so rushed. We're trying to get so much done so fast, and it's real easy to forget stuff. So anything that makes you slow down and think about that, probably not a bad idea. By the way, you can get a lockout kit at Home Depot for less than $100. So just something else to think about. And of course, the one in the middle, we all know what a grounding stick is. I won't give you the other names for it, but we all know what those are too. One thing about this, like a lot of the newer gear runs lower voltages, everything's behind screwed down panels. So like if you look at one of our boxes, there isn't a grounding stick in it. Now, if you're working on one of our AMs, there might not be anything in that transmitter that you can get to that'll hurt you, but you still got ATUs, maybe phasers, definitely the tower. I had a guy once, I was at a site, U.S. military, one of the AFRTS sites, and these guys, they're E5s, they know a little bit, but what do I say about IT? I know enough to be dangerous. My IT guy would agree with you on that one. But we were out looking at the tower. We just got done putting a 50 kilowatt AM on the air, and I just finished showing them with a 2x4 how you could lean against the 2x4, lean it against the ball gaps, get them a little closer, and they'd arc with the modulation. And as I'm pulling the 2x4 back, this guy goes to lean his arm on the tower. And 50 kilowatts of AM will mess up your day. So again, use the grounding stick whenever you're working on something, especially on an AM, because when you think about it, the weird thing about antennas is they will receive as well as they transmit. And I've had a guy in Paraguay, he shut down at 200 kilowatt AM. He very dutifully grounded the output of the transmitter. But it was 700 feet from the output of the transmitter to the base of the tower, and there was an ATU in the middle. So electrically speaking, got no idea what the base impedance was of that tower with the transmitter grounded so far away. I can tell you it wasn't a short circuit to ground because the 200 kilowatt transmitter 2 miles away that was still on air was putting enough signal into his antenna to give him second degree burns when he touched it. So by all means, ground everything. It's not paranoid if they are out to get you. So yeah, just pay attention to that. And then the Volt Alert on the left, of course, is a really cool toy. I can't believe after all of the articles we see about this being hacked and these broadcasting this and RDS being compromised and that I can still hit my favorite IoT search engine and find barracks boxes with no passwords at all and raw audio feeds and station IDs or in one or two cases, Nautel transmitters using the default username and password, which anybody who wants to spend 5 seconds with Google can find in one of our manuals. Don't use the default passwords, please, please, please. And by the way, password, also not a password. Neither's admin, for what it's worth. So, yeah, change those. I'm not a fan of regular changing, like changing the password every 3 months. I'm not, because that tends to lead people to write it down where you can see it. Anybody remember when Hawaii broadcast the missile, the nuclear alert, and they showed the screenshot of the guy at his computer? And if you zoom in, you can see the password written on a sticky note stuck on the front of the computer. So the guy's username and password are right there. I bet he changed it like very second after, or shortly after that news clip aired. But again, like I said, I'm not necessarily a fan of forcing them to be changed on a regular basis, but at the very least, find something different. And I mean, it might be something as simple as On Air 88.7, which is the station that I volunteer at. And I mean, just substitute numbers for letters and spaces and characters or whatever. But pick something and change the defaults. And use a VPN. Now, this is the one in the picture here. This is TunnelBear. It's a free VPN. Well, I use the paid version. It's not a whole lot, and that's what I use for doing stuff when I'm on the road with my personal machine. The work machine is pretty well VPN'd anyway. But the VPNs these days are so cheap and so easy to set up that there's not really an excuse not to use one. I was searching today for, again, using my IoT search engine. I found one of our new alpha model, one of our newest transmitters. They're beta testing or alpha testing the new user interface for it, and they left it connected to the internet without having it behind a firewall. So guess who got to play for a little while? Because son of a gun, if it wasn't the default password, it's not the default password anymore. Actually, I assigned a password and then shut his transmitter off and waited for him to call engineering. So, absolutely use some protection there. Scheduled inspections, like I said, with the air filters, you're the only one that can decide how often things need to be done based on your specific sites. But have a list. More and more, I use one of my electronic assistants, and I'm not going to say her name because she's right up there, and then she'll be wondering what to do next. But I use those. I mean, I've got reminders to change the furnace filters, to exercise the generator, to go up on the hill and test the backup STL, whatever. So, have it done. I mean, it's easy to say, set a reminder on the first of every second month or every 2 months on the first to do this. So, absolutely, whether you like that, whether you're more old-fashioned and prefer to write stuff down, and I've got notepads galore over here beside me, whether you use your electronic device of choice, don't care what you do, but you have a list, checklist for doing the scheduled stuff. It's way too easy to say, I'll remember to do that. Okay, a little side note, everything I do, like I said, everything's got a story. In Vegas, this little show we do every April. And the funny thing about Vegas, much like New York, is in April, we can get this frozen precipitation stuff that doesn't just disappear as soon as it hits the ground. So we got a foot of snow, give or take. And I don't know anything about it. I'm in Vegas until the phone rings. Well, when I'm on a show floor, there's only 2 phone numbers that will break through my phone and make it ring. And one of them's my mother, and the other one's the real boss. And it was the real boss this time, so I picked it up and said, hi, what's wrong? As she also won't call me unless something's on fire or otherwise sideways. And she said, power's out. Had a snow. And I said, oh, that sucks. And she goes, no, that part isn't the part that sucks. The part that sucks is when I went to the generator with this little sheet of paper you gave me and pushed the little red button like the little sheet of paper said, nothing happened. Then I said, oh, oops, been a little while since I tested that. Maybe the battery's dead. You haven't lived until you've talked to your non-technical wife into jump-starting the battery on a 9-kilowatt generator from several thousand miles away. But I promise you my generator has been tested fairly religiously ever since then. And she may or may not remind me every time I'm getting ready to go on a trip. So absolutely, like I said, you got all the electronic reminders you want, but there's nothing better than an upset wife to never let you forget anything. So do whatever it takes to do that. And like I say, checklists. And your checklist may be something very, very general. It just may say generator and put a date beside it or whatever. I mean, as long as you know what needs to be done, that's up to you. The other thing we have an issue with more and more as engineers and technical folks, and I see some people on the list that recognize several names. I see some people who I know are really good at this, and I know I'm historically not. But a lot of times we want to replace something because the old one's getting hard to work on, and maybe parts seem to be getting a little expensive. But unless you can quantify that, there may be a return on investment reason not to replace something in some case and to keep repairing it. There are definitely, and pain of use is one of the reasons. Look, I'll give you an example. At my station, we just replaced Rivendell, which is a perfectly acceptable automation system for some folks. For us, where we run 30 volunteer hosts who went from mostly all being in the studio to 100% of them not being in the studio, using it to import stuff became a real pain in the rear. So we ended up changing out we went to Playout 1. But again, sometimes the pain of use is the reason for making the change. It's not that there was anything wrong with the old system per se. So factor that in there. Everything has a value. The one thing I tell people is for every station you work on, you should have a reasonably good idea by the minute, by the hour, by the day, what that station bills, or if it's non-com, what it underwrites. Because only then do you know the cost of being off air. I mean, over and above the fact that once you lose a listener, you don't get them back right away. So, and I'm watching my wife, who again, non-technical, but a very avid music fan and radio listener. And I watch her, and it's 4 seconds from the time the station goes off. 1 second to realize that it's off, 2 seconds to wait, and 1 second to hit seek. So that's the basic guideline that I live by. And, if you've got something that's knocking you down on a regular basis, that's something else to factor in. All right. Next thing, interface. I mean, obviously, we're all here, so this is part of that, whether it's SBE meetings, whether it's regional shows. I know Chapter 22, was it, had the Upstate show last week. NAB New York's going on this week, or was just wrapped up right away. Next week, let's see, tomorrow, Saturday, I'll be in Georgia. Next week, I'll be in Kansas. The week after that, I'll be after Kansas, it's Indiana and Ohio. So definitely interface with folks as much as you possibly can. And this comes back to what we were talking about with the mentoring and the getting the young folks in. If a young person asks a question, by golly, answer it. I put Facebook up there. And I put it awful close to the Nautel logo, which is kind of irrelevant. I had something else up there that was time stamped and obsolete. But there's a Facebook group for just about everything, whether it's transmitters, studios, different automation systems, whatever. But find a place. There's always somebody out there that'll know the stuff. I showed this picture. And the boy happened to be walking by, and he's a teenager. He's 13, and he goes, "Oh, cool, the save icon. What are those?" And I felt my age. But absolutely backup. The other thing about backups is that they need to be air-gapped. I've run into more sites where they've had an issue, and I said, backup. And we had backup. So what's the problem? Well, it was connected to the main machine. It was connected to the network. So when whatever killed the main thing, backup came up and it got infected as well. So definitely air gap the backups. Don't leave them physically connected. I had a customer in Lake Geneva. Well, not one of my customers, doesn't matter, good friend. And she was saying that They had backup. Their procedure said air gap it. It was running long one night, and whoever was tasked with the backup had a dinner schedule that they had to get to, dinner meeting. So they said, well, no worries, I'll be in the morning. I'll unplug it then, and we'll be good to go. Except, well, somewhere between them leaving and coming in the next morning, Trojan fired, and now there's ransomware. And life is good until it isn't. So, yeah, absolutely. Do the backups and don't leave them connected. I mentioned power line protectors before, and a power line protector, so MOV, like I said, it's a great surge protecting device. Silicon avalanche diodes is the other one that you see a lot. They protect by detecting an impedance across them. Well, if they don't have a reference point to ground, then they're not doing any good. So I know the old surge protectors we used to provide had a ground stud on them. A lot of the newer ones use wiring to the actual AC ground. Either one's good. Here's something that you got to remember that used to be 10, 15 years ago now. It wasn't part of the NEC, and a lot of the older electrical inspectors struggle against it. Your station ground, your AC, your RF ground, what the coax cable is grounded to, and the transmitter and everything else, needs to be connected to the power company's AC ground. If they're not physically tied together, then you've got an impedance between the two, and you don't know if your surge protector is going to do you any good or not. It'll sit there with the lights lit, and that's wonderful. But first storm comes up, transmitter blows up, support gets a call, hey, this transmitter's a lemon. It blows up every time there's a storm. Surge protector never flickers. Perfect example. If the surge protector doesn't have a solid ground connection to the AC ground, which needs to be bonded to the facility ground, and for what it's worth, Article 250 of the NEC has said that since about 2010. So it's actually part of code now that they have to be bonded. But like with radio engineers, electrical inspectors are not typically, they're starting to age out as well, so sometimes you need to do some educating. Okay. This, because I figured I should finally walk the walk after talking the talk for so many years, this is the ground at my house. What you don't see is the video of that thing actually spinning around because it's not. Have I mentioned what I thought about compression connections? That's what that wrench is in the bottom for. So it was tightened, and then I finally bit the bullet and brazed it. So, yep. I am a huge fan of exothermic connections, whether it's brazing, Silphos, silver solder to a lesser extent. CADweld, love CADweld. I mean, you can buy CADweld molds on Amazon now. You just specify what you're bonding to what, and you get that, touch it off, and bang, you're done. It's permanent. So yeah, absolutely. Whenever you can, use an exothermic connection, whether it's brazed, ground strap. If you fold a ground strap over to make an angle, braze or solder, brazing ground strap can be tricky, but solder it at the very least, the fold, so that you don't have, because otherwise, what do you got? You got an inductor once it oxidizes a bit. Okay. This is one of those HD radio ones, and I did a paper at NAB several years back about the quote unquote dispelling the myths and some of the things that really seem to hang around with respect to HD radio, and one of them was the sizzling, the artifacts. And one of the biggest challenges that I've run into is up converters, or you can't put the bits back once you take them out. And I'm not an audio guy. I'm an RF guy. So, my knowledge of this is somewhat limited, but I know that much. So, yeah, absolutely. Up converters, if you can avoid them, don't go there. I'm not a big fan of I'm just not a big fan of converting, but sometimes you don't have a choice. By the same token, pick a level and stick with it. So somebody who teaches a lot of these courses and is a really good engineer called me one day and said, we're having trouble getting the HD2 to the same level as the HD1, or maybe it was HD1 in analog. So I walk in, and I had a bit buddy with me, one of the little Ward Beck bit buddies. And he had 3 dBFS over here, 2 dBFS of the minus, and minus 8 over there. Everything was at a different level. And so by the time it got to the importer or the exporter, whichever it was, there was no more give. They were running it. The gain was running at the wall, and there just wasn't enough level. So we started way back at the mic processor and started walking our way through the system. And we picked -4 dBFS just as a number. It doesn't matter. But when we got to the transmitter, we set that to -4, and all of a sudden the audio is at about 400% modulation. We backed it down at -4 all the way through. It's amazing how things fall together or come together when you've got a standard level. By the same token, if you're putting in a new piece of gear, you had something fail, you know exactly what it should be. Troubleshooting, going in, going out. Again, and I don't care whether you're digital audio, analog audio, whether it's DBU, DBM, or DBFS. If you've got a constant level, it makes your life so much easier. There are going to be times when you don't have that option. There's some pieces of gear where the only way to balance the output is to unbalance and when I say unbalance, I don't mean unbalance from the audio, but to have different levels on the inputs. So, that sucks, but you deal with it. So just pay attention. This one is a little bit of a pet peeve of mine. At the very least, when you get a software update, and I don't care whether it's one of our boxes or anybody else's box or a non-transmitter at all, look at the release notes and see what that update does, because sometimes that update will do something that we used to do with a bag of capacitors, resistors, and a sheet of paper that said, hey, cut this track, install this from here to there, jumper that over there, and this will keep you from blowing up on a lightning storm. These days, we can change bias levels, we can change protection thresholds. All that stuff can be done in software. So pay attention at the very least to the release notes before you decide not to install that update. Okay, remote access. The only really big thing about, okay, here's my dad joke. There had to be one. Running joke. Anybody who likes to go hiking, go for walks in the woods, whatever, if you do that and you're in an area like I was down in Virginia a little while ago, make sure you coil up 10 or 20 feet of fiber optic cable and stick it in your pocket. That way, when you get back in the woods and you get a little disconcerted and you're kind of lost and you don't know where you are, you can take that out of your pocket, roll it down, sit down, have a granola bar, whatever. And in about 15, 20 minutes, a backhoe will come by to cut the cable and you catch a lift home. So the big thing about fiber optic cable is it's not a matter of when the backhoe cuts it, or if the backhoe cuts it, right? It's a matter of when. So have backup. Here's the trick. I had somebody that said, yeah, we got backup. We've got Comcast on our main and, Bug Tussle Wireless on our remote, or on our backup. I said, that's really cool, but who does Bug Tussle, what do they use for a backbone? Turns out they were running on Comcast. So when Comcast goes down, so does your backup in their case. So make sure that if you have redundant IP links, that they're not running on the same backbone, even if they are different ISPs. And that's something that can bite people a lot. Okay. Breaker requirements, that's basically the same as figuring out heat load and just factoring in efficiency to get current draw. So, that's all you need to do there. Remember to add a little bit of a safety margin. Breakers don't like to run at 100%. They tend to get pretty toasty when you do that. And that's where your FLIR camera from a whole bunch of slides back comes in handy. Okay. And please, please, please clean gear out. I can't tell you, this is a site in Louisiana, and they were complaining that every time the humidity got up, like it was raining out, the transmitter would start kicking off. Well, this was down on the power transformer. That's a snubber circuit. But the funny thing was, all the control boards looked the same way. Louisiana, so humid in Louisiana is about 115%. I mean, I have been standing in Louisiana and watched raindrops forming in the sky, in the air in front of me. It's the weirdest thing ever. But anyway, so yeah, absolutely, keep stuff clean. I like vacuum because it's easier to remove the dirt than it is to blow it from a place where it wasn't causing a problem to a place where it might cause a problem. So definitely a fan of vacuums. Okay, LTE interference, if you haven't had a case of it, you will. You can't build a 5G rollout putting all the sites further apart by 100 feet than they need to be in order to minimize, because, well, when you're doing a nationwide build out, that's a couple of $1 billion saved. When you're trying to hit a threshold of minus 120 dB, and that's what the cell carriers are looking for in a lot of cases, cabinet radiation, any loose wire on an FM tower, it all comes back to be an issue. So I wrote a paper on this about 5-6 years ago. Had John Garziglia rather, provide the legal thoughts on it. Got some information from a whole bunch of people smarter than me. You can find it on our website. I think it's called. You go to support and then go to tips and tricks and scroll down. You'll see one that says, "Can you hear me now?" Seemed like an apt title for an LTE interference article. But anyway, so absolutely, I'm not getting into it a whole lot, but it is something that is becoming more and more of an issue. Okay, we mentioned IP security. This is the sort of thing we have gone to a hard zero trust policy at Nautel. For those of us who have been here since the network was created, I mean, when I started 32 years ago, we had an 8088 and an 8086 connected with a piece of coax running Lantastic, and that was the whole Nautel network. These days, and so I've had pretty much unfettered access, and then all of a sudden I go into stuff that I used to be able to cruise, and they're saying, no, you can't go there anymore. And it's like, but why not? Then stuff like this is why. So absolutely, zero trust is a good way to get there, but a lot of us don't have nearly the IP security we should have. Okay. Mentioned site maintenance. I'm going to blow through the last few of these. We're running close to time, but definitely, again, whether you're running, if you're running diesel, fuel conditioning is an issue. If you're running propane, then battery checks, belts, filters, that sort of thing. Again, specific to your machine. If you contract this stuff out, make sure you've got a list of things that you want them to do. It may or may not match what they've got on their regular scheduled maintenance list. Okay. Shorting stubs can help you out for a bunch of stuff. If you've got something that is prone to issues during transients, shorting stub will sometimes help. Again, back to that tips and tricks page that I was telling you about, where if you go to support, and I think it's technical resources, there'll be tips and tricks as an option. There's one in there about how to build a shorting stub. You can make your own. All you got to factor in is the velocity factor of the cable. So it's pretty easy, and it's a really cool thing to do, just for the fun factor, if nothing else. I love deoxit. Anything you've got, anytime you got two things that plug into each other, there will be some oxidation at some point, depending on your environment, and things can get a little staticky or noisy or intermittent, and this stuff works really great for that. Let's see, Deoxit Pro Gold. I like the liquid better than the spray just because I've got more control, but that's totally up to you. This used to be called Cramelin Red in another life, and Keg Industries bought Cramelin, and now it's Deoxit. All right. This one I'm a huge fan of, PPE. It's shock resistant. Now in the U.S. it's called EH rated, electrohazard rated. And I see Jeff looking at the clock. I've got 5 slides left. We're blowing through them. But yeah, EH-rated footwear will keep you alive if you do something stupid. And I know this because I've done something stupid more than once, and here I am. So absolutely, you can buy them at Walmart. Red Wing Shoes makes them. You can get them in sneakers, work boots, whatever, and they will save your life if you get across something. So by the way, air conditioners, you can't oversize them. So make sure that, again, work with an air conditioner tech. Like I said, not just the equipment, but the building, but make sure that you don't go too big. These are the coolest thing ever. Second last slide. Winford Engineering in Detroit makes these. If you've got anything with D connectors and you're like me and you're getting old and stubborn and don't like solder and D connectors, those things will save you a lot of grief. A 25-pin one is about $25. They make them for all different sizes. There are other companies. That just happens to be the one that I know. So, yep, that's a cool one. One other thing, we have an RF toolkit on our website. We do make you sign into it. They do send me a report. I cheerfully ignore it. But it is cool because it will allow you to do point-to-point coverage plots like the one I've shown here. And it'll show you the Fresnel zones. It will also, and this is critical, if you're using the Ubiquiti tool to do a point-to-point plot for like an IP link, remember or realize, be aware that it does not factor in foliage. So if you've got 60 feet of old growth forest in your way, that could be an issue, and you can turn that on and off with our tool. It's free. Like I said, we do track it, and I think they send me a report every year or two, and I've never paid attention. All right, other resources for the record since we're recording it, and I didn't hit it exactly at 8 o'clock, or 7 o'clock your time, but hey, we got close.
Yeah, no, great job there. Most folks just run off and run and run and run. Do you have the contact information for yourself?
I do. You can find me at jwelton, JWELTON, at Nautel, NAUTEL.com. Or you can find me on Facebook. Most of the engineering pages on Facebook, LinkedIn. I think I've got an Instagram account. I don't do TikTok.
Not yet.
That's probably a good thing.
So one of the reasons I wanted you to present was because Nautel transmitters are everywhere these days. Use the phrase "the big dog," and if you're in the radio broadcast business, if you haven't seen one, you're going to see one. I want to make it really brief, 5 minutes worth, if for questions, comments, queries. So just remember, we're going real brief because people get hungry at this time, and if you don't feed an engineer, you don't want to be near them.
Bad things happen.
For disc jockey.
Yeah.
One quick comment. I remember, Jeff, you may remember this, the grounding stick. When I took the tour with you at the AM transmitter at WLNA.
Yeah, I took you with me one night, a late night, and I told you if I got zapped, just push me out of the way and call for help, because it was at the point where I was by myself.
Right.
And Langdon was one of the DJs. So he's asking me all the questions, what does this do? What does that do? And I had to do some late night repair, whatever. But, I was like, Langdon, can you make it to the transmitter and make sure I don't get fried? And he did. Yep. And I'm still here.
I did. I remember the grounding stick. Yeah.
And that is a huge one, though, especially as we get older and tireder and there are fewer of us doing more stuff, is try as much as you can to drag somebody out with you. And they don't need to be technical. All they need to know is where's the circuit breaker and how do you call 911?
Yeah.
We actually had one of the disc jockeys had worked at WHN, and there was a story of one of the engineers getting electrocuted because he really shouldn't have been there.
I have a slide deck, and I'm not going to drag it up now, but one slide is nothing but a list of headlines, basically including the phrase "engineer found dead at site."
Right.
And out of the 5 of them on that slide are all people that I knew. So let's not contribute to that.
It's always something to be aware of. And I made in years past a lot of late night 3 a.m. Appearances at the transmitter site, and I was tired, and it's got to be the first thing in mind for everybody is safety.
Yep, and that's a good point too. If you do have to go out there alone, at the very least, have a call-out schedule. And the funny thing is, it's not like of the 5 I know of that have died at site, 2 of them had heart attacks at the site. It's not known whether they got electrocuted, but they weren't near any exposed electricity at the time. They were just older and working too long and overstressed. One guy slipped on something and hit his head on had an exciter drawer pulled out and hit that, concussed himself and bled to death on the floor. So again, he probably could have lived if there had been anybody else there.
Yeah, we got to make this aware for the SBE people, because no one else is going to look out for us unless we do it ourselves.
Right. Yeah. Nobody looks after your safety but you. I mean, you go walk into any bathroom in our facility, there's a sign at the very top corner of the mirror that says you're looking at the person responsible for your safety.
Anyone else?
Yep.
Okay, it's quiet. Last call. Anyone else?
Yeah, I have a quick question.
Yeah, Andy.
When we're doing, I'm having an issue, and it's not a Nautel issue, but it's just trying to
Doesn't matter.
I have a FMQB RDS encoder that when I put in the line, it starts to really push the modulation a little too hard, and I've dropped the voltage down, a lot. And then, if I use the little meter, the handy dandy little SCA injection meter that the Nautel comes with, it shows me my ejection level is too low. So when I push the ejection level up, the modulation starts creeping up to like 110, 111. What am I doing wrong here?
So you said this is this connected to one? Like, how are you reading the modulation?
I'm just using the transmitter control page on a VS1.
Okay, so on the VS1, the first thing to remember is that the modulation meter shows you everything. So it shows you your stereo pilot and your RDS and your audio.
Okay.
So factor that in for sure.
All right.
So if you're running stereo as example at with 9% injection, well, there's 109% before you even add the RDS.
Aha.
So if you're adding the RDS at 5%, then I would expect to see 114% on the modulation meter. And remember, at that point, you are going to want to back it down 2.5% because you can only reclaim half of what your Oh no, you could have gone up 2.5% to cover half of what you're. No, I'm backwards. You would have to go down 2.5 because of the adjustment for the modulation for the RDS injection.
So back it down on the SCA injection page?
On the audio level. So remember, you're allowed 100% mod theoretically, not counting pilot, of course. So when you add 5% of RDS injection and you go to 105%, you're allowed to claim half of that toward your modulation. So you would have to back the audio down to 97.5%. So you showed 102.5 total when you factor in the 5% RDS.
Got it.
Okay. Now add the 9% for the pilot, and let's say it's easier for me to draw the picture than to explain it with words. But that's what you're running into.
Got it. Okay, makes sense.
I used to do a lot of SCA work, so I'm very familiar with that. Andy, if you want to talk, but I think you may already have your problem solved. Okay, it's dinner time, folks. I'd like to thank Jeff Welton for joining us. I really appreciate this, and I'm sure most folks on this call can tell you how much they love their Nautel transmitters. And we'll have this posted online for folks who couldn't be here so they can watch it from our YouTube page. Thanks again. Thanks, everybody, for being here, and we will see you next month.
Thanks for joining us. Please remember to subscribe to SBE 15 New York City.